Question 500, keyboard row. Now, this question is asked many times by Amazon, so today I'm going to be going over this question. Given an array of strings words, return the words that can be typed using the letters of the alphabet on only one row of American keyboard like this image below. In the American keyboard, the first row consists of the characters QWERTY, U, I, O, P. The second row consists of the characters A, S, D, F, G, K, E, blah, 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 blah. Third row consists of these characters, right? So looking at this basic image, we have this first row, which is a group, this second row, which is a group, and this third row, which is a group. Looking at this example down below, we have an array of words, and the output is basically which words can be typed using only one certain row. So the first word is Alaska, which can be completely typed with the second row. This second word is dad, which can also just be typed with the second row. Okay, so sort of off the bat, what sort of solutions are you thinking of here? Well, given by the question, right, we have three groups. And each group is very specific that when you're typing these words out, you can only use letters from that group. There's no mismatching. There's nothing advanced, nothing like that. Okay, so sort of thinking up some solutions here. We're going to sort of brainstorm some data structures that could work here. Well, thinking almost immediately what could be some good data structures here is actually the hash map, which is one of the most important data structures in all of Leetcoding because it can solve so many problems due to its constant lookup time. And that is important here. Under the hood, the hash map basically uses a hashing function to map keys to values. And this is important because it gives you that constant lookup time that helps the time efficiency be so great. Okay, so using this hash map, let's think of some general pseudocode to this solution, right? Well, what if we mapped each of the three groups, like we said before, to three different map values, okay? So let's basically say the first row is mapped to 1, the second row is mapped to 2, and the third row is mapped to 3. So those are three rows that are mapped, okay? And then once we have this general mapping down, we can then iterate through all the words. So loop through words. And the first thing we're going to do for each word is we're going to iterate through each letter, okay? So for each word, loop through each letter. Now you might think, oh no, this is like O of n squared, but it's actually not because we're still only touching each letter. We're not like double dipping, right? Okay. So we're going to actually be using a few variables here. And I'll write this in red so they're clear, okay? First variable here that we're going to use is previous. And this is going to keep track of what group the previous letter is in. And if we have a word that has all of the same letters, that means every single if we have a word that can be typed only using one row, like dad here, right? Then that means all of the letters in dad, D-A-D, will map to the same group, which is group 2, okay? The letter D will map to 2, the letter A will map to 2, and the letter D will also map to 2, okay? So basically what this previous variable is doing is making sure that all the characters map to the same group, right? Also keep track of just a Boolean value, which makes sure, like, is this a valid word? Like, should we output it to the return value? And so using these two variables, the first thing we're going to do in each letter is check. Is previous equal to 0? And if that's true, then we're going to set previous equal to the map of the first letter. Okay. Now what this code basically does is first letter of each word. So first letter will set the previous value. Okay. So looking back at dad here, sorry, this is becoming kind of crazy. Might be hard to read here. This will set previous to 2 because it's the first letter in the word. The previous will be set to 2. Okay. Else, it means it's any other letter in the word. Right? And we basically just check. It's a quick check. If the map of the current letter does not equal previous, that means that the groups are not the same. We just set valid to false, and we break out of the loop because that means basically this word is voided, and we can move on. And then finally, we are out of this body of code, and we are at this loop. We want to just check, is this a valid word? If it is, we're just going to append it to the resulting list. Append to result. Goodness, my handwriting is terrible. Sorry about this. Okay, and then we have our result list. We basically go through and we return the result. Okay. Now this pseudocode might look like spaghetti code to you, but hopefully by doing it in Leetcode and actually showing you out type by type, I'll be able to explain it in a much better way. So let's go ahead and hop into Leetcode now to show you that exactly. Okay, so the first thing we want to do in this code is to set up our variables that we're going to be using for the entirety of this function. So we're going to have a result list that we actually return. We're going to have our hash map that stores the different groups. So 1, 2, and 3. And then we're going to take an array. And sorry, those brackets are the wrong type. We're going to take this array and we're going to have word EUOP, this is the first row. We're going to have the second row, which is as difficult, blah, 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 whatever. I can't speak. That's our second row. And our third row is going to be ZXC ... whatever it is. Whoops. Okay, so these are our 3 groups that we're going to put into an array. Okay. Once we have this set up, our first step is to initialize our hash map of the 3 groups. The way we basically do this is iterate through our array that we just created. And we're going to use the length of the array there. And for each item in the array, we have to iterate through each letter. So we'll just say J in this case of that group. And we're going to fill the map. So the map of that letter, the key will be the letter, which will map to I plus 1. We're saying plus 1 just so that the groups can be named 1, 1, 2, and 3. And if you prefer to do 0, 1, and 2, it makes no difference. I'm just doing I plus 1 so that it's called like that. But you could do just I for that case, and it would not change the code at all. Now, once we have that set up, right, we're going to iterate through each word in the words array. And here's where we talk about the previous variable that we're going to use. Previous is initially set to 0 because we don't know what it is yet, right? We have the valid, which will keep track of should this word be put in the result array. And then here's 2 things I did not talk about in the pseudocode. The first step is taking our word and actually putting it in a saved word variable. Now, the reason we do this is because in order to accurately compare the words with the letters, we're going to actually just take word and make it lowercase. So it's just a small little step there that could mess you up if you do not think about these types of clarifying cases, right? With that being said, it is now time to iterate through each letter in all the words, okay? This for loop is actually going to be within the for loop of word, but this is not of n squared because we're only touching each letter of the word, okay? Now the first check we make is if previous is equal to 0. Now this basically means that we're on our first letter of the word. We're just going to set the previous equal to the group, okay? So this check only counts for the first letter of each word. And the previous will be set to the group of that word, right? So if the first letter was D, then it would look at the group of D and set it to 2, or whatever D is, right? Next, we have all the other letters, right? For all the other letters, if the previous mapping is not equal to the mapping of the current letter, then this word is no longer valid and we can go ahead and break the loop. Okay, so this is the general code that you need. And then finally, at the end of checking each letter for each word, if that word is still somehow valid, which means we iterated through all the letters and they all worked out, we can go ahead and append that to the result. And here is where the saved word variable comes in because we do not want to put the lowercase variable. And finally, after this entire block of for loops, we just return the result list, right? So with this general code here, let's go ahead and submit. And looking at our submission, our runtime was 32 milliseconds. It beat 78% of users with Python 3, and our code did quite well. Now, if you want to learn more about this specific problem, then go ahead and click here to learn more. Thank you so much for listening once again.